Hi, Ishan.
Oh, hello. Yep.
Hi. Lots of confusion.
Yeah,
So your time changed when? When
yeah,
did
it
you?
has.
So please inform me whenever it does, right? Because
Okay.
our like in India, time does not change, never changes. It is uniform.
Oh,
But in Australia, if it changes, then our schedule is different. Your schedule is different.
yeah.
Okay. So now, my 11:30 has become 12:30.
Hmm.
So my 12:30 is your 5 p.m., right?
Yeah.
So there was a confusion. Yesterday also we could not have the session. So tell Vivan that Thursday we have a session with Vivan. Right? So Vivan, we will have this session at 5 p.m.
Okay.
No. Okay, so
Wait, it's chemistry on Monday, and then it's biology on Tuesday. So then
yeah.
when is physics?
No, no, no. See, physics will happen uh, in the bio schedule because currently you're doing what topic? Tectonic plates, right? At school.
Yeah.
So do it with bio tutor. And when
Hmm.
physics portion will start, then I will come in the same schedule.
Oh, okay.
Right? Only Monday and Tuesday are the sessions. Right?
Yeah.
So if chemistry is over and you're doing some other topics, like I can take some sessions during the chemistry sessions also, no problem, right?
Mm.
What happens? So at this time you're doing biology at school, so do biology with the bio tutor,
Yeah.
and then when physics starts, I will come in again. So only
Yeah.
two sessions, right? Monday and Tuesday. No extra session.
Yeah.
Just like before, Monday and Tuesday. But whenever you need bio tutor will come in. Whenever you need physics tutor will come in. Got the point?
Yeah. Hmm.
That's
Oh, and I also talked
so,
to my mom about the holiday thingy, the holiday thingy. So she said, do you want to rest or do you want to keep going? I said, since we're not really learning anything in school pretty much, I said, can I just have a rest instead? And she
okay, but
said, okay.
okay, just tell me from when to when you'll be away. It's okay, you can take this, right? No problem.
Uh-huh. Oh, it ends at Thursday, I think, the school.
So from which date to which date? Do you have any
So,
idea?
so from Thursday up to 24th of
This
April.
from this Thursday?
Yeah, this Thursday till 24th of April.
So this Thursday is falling in this is Tuesday,
Yeah.
4, 5, 6. 6, right? Thursday, 6 to 24.
24.
24th April, right? Okay, fine.
Yeah, it's pretty big.
Okay, okay, you can take the gap, right? No problem. Just message me whenever you want to start the session. So from the next week, you will not have the session, right? That
Yeah.
is the thing. What about Vivan?
Vivon, I'll ask my mom for that.
Okay.
Or yeah.
Okay, so there is.
Yeah.
Okay. So what were we doing in?
Oh yeah, we were talking about convection currents.
I think that topic is pretty much done, right? Everything we
Yeah.
have done it. So we will start a new topic today.
Hmm.
So your chemistry sessions are going, right?
Yeah.
So what I'm doing, With Hitesh, your classmate, I'm doing waves, energy and waves. So let's start that topic.
Okay.
He told me that this tectonic plates are going, but tectonic plates. Yeah, biotutor told me that you're already very interested in was right geography.
Yeah,
Geography.
because I'm
Yeah,
going to geography, that's why.
yes, he said that he's already very good at it.
Yeah.
You like geography very much?
I like geography. History, I'm not really much of a fan of because I don't know. But geography, I don't know. I guess I'm just better at that than history.
Really? What do you like about geography?
Um, maybe just the landscapes.
Landscapes, okay. And my geography is very, very, very weak.
Oh, oh, yeah. Um, yeah,
Okay. Energy and wave. We will do energy and wave. Just a second.
yeah,
Just see the book. This is your book.
yeah. Energy and waves.
So we will do this topic today.
Mhm.
So what are you doing for holidays?
Um,
You don't want to study. You just don't
yes.
want to study. You want to have
Yeah,
fun.
I
You
haven't
know,
really thought about it actually. The holiday, what to do.
so you're going on a vacation or tour or travel.
I don't know.
You're not going anywhere, but you don't want to study. Oh, I don't want to touch the
Yeah,
books. Okay, have
yeah.
fun.
Reflected by clouds, reflected by sky, sound waves,
Okay, so
sky.
energy and waves, light waves and visible light, we'll talk about it. Transverse wave, longitudinal waves, uh, and then wave equation. This is the wave equation. Yeah, at least this much we will do today.
Also, did you know the sun takes like 3 or 2 minutes for light to reach Earth?
It takes 8 minutes.
Yeah, something like that. I
Yeah,
thought it would be like instant.
no, it takes 8 minutes. So see how distant is the, if you multiply 8 minutes with the speed of light, you will get the distance of the Earth and the Sun. It's a huge
Earth is like
distance. But
very huge.
convert 8 minutes into seconds and then multiply the speed of light with that time. 8 minutes
Yeah,
multiplied by, what is the speed of light? Do you know that?
I don't know. Oh, and I said extremely fast.
Okay. What do you mean by one light year? You know?
1 light year.
Yes.
Um, I'm guessing that's how fast it goes.
No.
So
That's, do you have any interest in astronomy?
I don't know what that is though. Like 1 light year. I know I've heard of it, but I don't think I've really paid too much attention on that.
Okay, your mom is messaging you just a minute, right?
Yeah. Yeah, she's like right here. I don't know why she missed the message.
Okay, she's here. Okay, it's okay. Just tell her that there was a confusion due to this time zone change, right? Your
Yeah.
daylight saving. Whenever your time changes, just inform me, right? Before the
Yeah.
next session. Because our time remains uniform, your time changes, then we also have to shift the time a little bit.
Yeah.
I didn't know that Australia also uses the daylight saving concept. Other like Canada, USA is using it, and that is a bit of a problem for us.
Yeah.
Like usually it is 1 hour shift, right? 1 hour shift.
Yeah.
There is enough sunlight in Australia. Why are you using this?
I don't know. I mean, the southern hemisphere is already facing the sun already.
Yeah, like I can understand about Canada and USA. It's fine over there. It's very little sunlight that they receive. But here in Australia, it's already very hot, right?
Yeah. This is
What
like
is
one of
it?
the driest countries ever.
Yes. What is the temperature right now?
Um, okay, so the good thing is, so we have a season called autumn. So that's when the rain and the wind starts pouring in.
Oh, it's
Yeah.
good.
But still, that rule does not really apply because in the afternoon, it turned more than 30 degrees.
Oh,
Yeah.
30 degrees. What is the hottest you have felt?
I don't know. I don't think I've no, it's
Like
something like 40 something.
40, right? 40 is. You know what
40.
is the hottest temperature in Delhi, New Delhi, in India? It is
Um,
48 degrees Celsius.
that's hot, hot, hot.
That's really hot. It's like
Yes.
sucking your energy. Sun is sucking your
Yeah,
energy when you're out
yeah.
on the when you're very out.
But so um from year six or year five when I was there was this thing called a bushfire, and more than half of Australia was burning, and there was
Yes.
so much heat waves around the air, like it was so hard to get cool. So I don't know.
Yeah. I've heard about this thing, right? There is always like every year there is forest fire in Australia.
Yeah,
That's due to this sunlight, right? This is due to hot reason. It is very, very dry.
yeah.
Hmm.
But the driest place is Antarctica.
I've seen is koala or what? Koala is Australian
Koala.
animal? Koala was
Koala is a native animal.
so is it found in Australia?
Yeah, it is.
Right? Okay, yeah, that's what I saw. I saw a video that people were rescuing these animals when there was a forest fire.
Yeah.
So it is 4th of April, 14,403,04, 2023. Physics class. And
Oh no, my favorite part of geography is not the landscapes, it's the biomes.
hmm. So what do you like about science? Like, what do you
Science.
like in science?
I guess. No, wait.
Physics, physics,
Shoot.
chemistry, bio. Out of these three things, what do you like the most?
Wait. Physics, chemistry, biology. Biology, because it's geography.
Because there is no mathematics there,
Yeah.
and you hate mathematics.
Yeah.
How is your mathematics going on?
Oh, did the test yesterday, assessment, and
Hmm.
it was a bit difficult for me. So, for some people, they found it like okay and easy-ish, I guess. For me, I found it like easy-ish, medium, like tiny bit difficult though.
No. Like,
Yeah.
what was the topic?
Indices and number of any magnitude.
Number of magnitude?
Yeah, it's like about um. Okay, I don't know how to explain it, so I'm gonna just say
Scientific notation like 10 to the
yeah,
power
yeah,
16, something like that.
scientific
Scientific
notation.
notation. Okay. Okay. Let's talk about wave.
Yeah, waves.
What do you know about wave? What is a wave?
Um, they're made of water.
Water wave, only water wave, you know?
Oh yeah, there's also sound wave, light wave, no, not light,
Correct.
heat waves,
Yeah, light is a wave, correct. You were right.
and
Light is a
and
wave.
the waves that are found in a microwave.
Microwave, correct. So you know these things, right? Wave optics. So if I ask you to define what exactly is a wave, I'll give you some pictures first.
What is a wave? Um, Wave is a constant flow of energy. Well, that's what I'm
Constant
guessing.
flow of energy. Yeah, you're using the right term. Oh my God. I didn't expect that.
Okay,
It's the energy, yeah. It is the flow of energy. Yeah, that's correct.
okay, yay. I guess that.
Let me get some pictures that will clarify your concepts.
Light waves, magnetic waves. Um,
Ever studied about waves before in your
uh, yeah, I've learned it
lower
in year
grades?
7, a tiny bit.
Tiny bit? Okay.
Yeah.
Water ripple. Have you ever created water ripple?
Oh, what vapor? I mean, you can do this thing where you can just get a tree or like a branch or something like of a small plant. It has to have leaves on it, and then you put like a plastic bag or something around it, like tie it, and then after like I don't know, days, like 2 or 3 days, you can see the water vapor on the bag.
See,
I hope it makes sense.
this is water ripple.
Yeah.
Okay. First, I'll define this thing, that what exactly is this thing. And then, what happened? What happened? What happened? I'm not able to move it.
Um,
Now I'm able
am I
to.
supposed to see the energy and waves booklet thingy?
Indian waves? No. Where did you learn?
I don't know, energy waves.
Energy waves. Wave is all about energy. Just see this. Let's see the definition of it. It is the propagation of energy. It is the propagation of energy.
Mhm.
This you can write.
Oh,
Definition.
I can't see the screen.
Up. My right.
Yeah, I see the energy and waves homepage thing.
This thing.
Yeah, now I can see it. Water,
Yes. It
water
is the
droplet,
propagation of
water
energy.
repudiation. What does repudiation mean?
Propagation means like moving from one point to another,
Oh,
like
okay.
flow, right? Flow of something. It is the propagation, like light propagates from the sun to the earth, right?
Yeah.
It is simply mean propagation means simply movement.
What is repudiation?
Repudiation. Where did
Yeah,
you get
R.
that word?
I didn't know. That water
Repudiation.
droplet.
Where did you get
Yeah,
that
that
word?
water.
I need to look up the meaning of it. That's a new word
Oh,
for me.
oh no. Okay, I just hope it's based on this topic because I just found it.
Repudiation.
This droplet made me think about it.
Repudiate, or to refuse to accept something, to say something
Oh,
officially, publicly, to repudiate a proposal or suggestion. Socialism has been repudiated at the polls. A simple one.
okay. So it's nothing to do with the topic.
No.
Okay.
It is the propagation of energy from one point to another.
Mhm.
1 point
Energy. Oh
to
yeah, I should probably write
another.
this down.
What?
I should probably write this down.
Yeah, yeah. You have to write it down.
Hmm.
Chemistry tutor told me that you're not doing homework.
Oh, I haven't.
Like,
I mean,
yeah.
I kind of
She
have, but
told, yeah, she told me that he is very good during the session, but he's not doing his homework. What is happening?
oh, I don't know. I mean, no,
Did she
I
give you
guess
any homework? Did she give you any homework?
she gave me a total of 4 homeworks. I done about 3 of them, but then the second or third one I don't remember
Oh,
if I did it or not.
so you're sending the homework as
Oh no,
well.
I think I've sent like her like no, I sent 0 homework. I just finished them.
Oh, you finished them. Oh, okay. She said that she hasn't received anything. You just WhatsApp her.
Oh,
No problem. You're
okay.
doing the
So
work and not receiving the credit. Just show
yeah,
her that you're doing the work.
okay.
Okay. No problem.
I just hope I have the time to finish most of the homework because I think the most homework I get is from the maths teacher.
Yes, math is all about homework.
Not just from her, but also from the school. The school makes me do like 15 questions as homework, which is approximate to like 3 pages or 4. And the maths teacher makes me do around 5 questions for homework.
Yeah,
If you do that plus that, that's around 20 pages. So not 20 pages, 20 questions.
just a second, right? Wait, let me message one thing.
Movement, propagation, energy.
Just a second, right? I'm just
Yeah, 1.2 another. Yeah. And since waves remind me of waves, I'm just gonna draw a tidal wave. There we go.
yeah. Okay. So it is the propagation of energy from one point to another in the form of disturbance.
Yeah. From one point to another. I also think my video like profile picture thing is a wave as well. But it's a water type of wave.
Yes, that is also a way. Yes. Form of disturbance. Okay. One interesting thing about wave is that there is no transportation of matter during wave propagation.
Hmm, no matter.
There is no transportation of matter.
There is no
During
okay, I don't know why, but some random words are popping into my head now.
like
First it's repudiation, now it's laceration.
laceration, lacerate. I've heard that word. What does that mean? You know the meaning? I think
Does
it's
that have something
something
to do with
related.
fire?
Yeah, lacerate or punishment. Something related to punishment.
Oh,
Lacerate. Yeah, during English sessions or what?
I don't know. Some random word keeps coming into my head.
A lacerated wound. Lacerate. Lacerations is a wound.
Hmm.
Oh, lacerate.
What's random is what came into my head.
Tear or make deep cuts in flesh or skin.
Oh.
Now, it's cut in the skin.
Cut in the
Lacerate.
skin.
Cut in the skin. Like
Oh,
when you're cutting your skin like that, that is lacerate. How that
oh,
the scary moving things when you cut your body into scratches in the body.
oh, okay. I was not expecting that.
Like where are these words coming from? In the context
I
of
don't
what?
know.
Did you watch some movie recently?
No, they just pop up in my head
You
for
don't watch
absolutely no.
movies?
No, I do, but they don't say language like that most of the time.
Okay, so see, it is the propagation of energy in the form of
Mhm.
disturbance. Here, two terms are very, very important to understand:
Yeah,
disturbance and energy. It means there is no transportation of matter during the these things are important. There is no transportation of matter, energy, and disturbance. So, disturbance, how do we create a disturbance? Let us say that this water is there, right?
yeah,
Still water
disturb.
will be something like this.
Dot, 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 dot. Water. That's a lot of water.
Yes. So just see if there is this kind of water, it is something like this water particles, right? Water particles, there are water molecules.
Water molecules. Water molecules are close to each other.
What is the chemical formula of water?
H2R, so two
H2O.
hydrogen atoms and one oxygen atom.
Correct. And do you know the structure? It looks something like
Um,
this, right?
I think so. Yeah.
Yeah, this is oxygen and two hydrogens are attached with it, right? Something like
Oh,
that.
okay.
So
Mhm.
oxygen, H2O. So, but here when we are talking about the bulk water, we treat all the molecules as spherical, almost
Yeah,
spherical, right? So these small dots are representing water molecules.
you can see molecules under a microscope, can you?
Now,
Oh, you can't?
under very like normal optical microscope cannot show you molecules.
Hmm.
But yeah, electron microscope can show you atoms also.
Yeah.
Do you know electron microscope?
Electron microscope?
Yes.
Um, I don't know. I think so.
The normal microscope, I think you have worked with normal microscope.
Yeah. Oh,
School. Your school must have some microscope.
yeah, they have. I've seen it before, but we were testing some pond water and there was so much stuff in it.
Yes. Pond water, usually that is used in biology, right? So biology stuffs like the whatever. The shell structure can be seen by that.
Yeah.
So just see that if there is a still water would look like this. Still
Mm-hmm.
water.
Still water.
Still water will look something like this. So it means all the molecules are, although the molecules are never stationary, but for the time being, assume that the water molecules are stationary, right? Something like this. So still water, there is no disturbance. Now you drop a pebble on it,
Oh, okay.
then
Then it was
just,
drifting here.
yeah, disturbance. Just see that all these molecules are coupled together, right? There is an intermolecular bond between them.
Yeah.
They're all connected with intermolecular forces. Something like this, right?
Oh,
So this
so the
thing,
thing, yeah,
yeah. Do you know these things?
yeah.
So so they are connected like this. And when we are talking about this thing, I have roughly drawn this thing.
Mm-hmm.
Like two molecules are connected like water molecules. They are almost like spring force. Like they are
Yeah,
connected together by a spring.
spring.
Like if you try to pull it, what will happen?
Oh, they're gonna come back to each other.
Yeah, it will try to stay at the same position, right? Something, suppose
Yeah.
there is a spring like this,
Mm-hmm.
it is attached like this. So what
Oh,
does this spring do? It has a tendency to stay the same, right?
yeah.
If you try to push it, it will,
Go back up.
very simple. Yeah. Like
Yeah,
if you try to compress it, like let us say that you're pushing it this direction, then it will try to uncompress it, right? Spring force will
yeah,
come in this direction. And whenever you try to pull it upward, it will try to bring it back. It always opposes the change in its state. It wants to stay the same. If you stretch it, it will
yeah.
unstretch itself. If you try to compress it, it will try to uncompress itself, right? So always opposing this thing. Now just see that they are all bonded with, like, let us say that these are the molecules. They are bonded with spring forces,
Yeah.
something like this. And now you're dropping a pebble on it. What will happen? Now, what will happen? You will disturb it, right? You'll create a disturbance. This molecule will shift here. It means you compress the molecule, right? Compress the molecule. Then
Yeah.
this will try to uncompress itself again back to this thing.
Yeah.
But when it is compressed, it will, along with it, it will compress, it will pull other molecules also, right? That is the thing. And this will go down, and along with it, other molecules will also be pulled downwards, something like this. Getting it? So that's what happens when you drop a stone. So many
Oh,
complicated things are happening, right? So all the molecules, although you dropped your stone over here, and then one molecule pushes the other molecule will push the other molecules, and in this way, all the molecules start vibrating. You see that what happens to this spring? This spring start vibrating, and if you drop a ball on it, if
mm-hmm.
this ball, like suppose you drop suppose this is the thing,
Yeah.
and there is a spring like this, and you're dropping a kind of brick on it.
Yeah. Brick.
When it lands on this spring, what will happen? It will compress a little bit,
Mm-hmm.
and then it will push the brick upward, right? The brick goes upward, and then it will again come back, again push it back. What will happen? Let us imagine that it will not like tumble down, it will stay the same, like perfectly landing on the spring again. Then it will start oscillating, right? Spring will also
Yeah.
start oscillating. That's what happens. So this pebble is bringing some energy with itself, and it distributes, it transfers this energy to the molecules of the water. And because
Yeah.
these molecules of the water, after receiving this energy, they come into the state of vibration, but they do not want to keep this energy. So they transmit this energy to the neighboring atom, right? Neighboring atom. And
Yeah.
that is how the waves are created. Here, the water ripples are created in this.
Mm-hmm.
Because each molecule is transmitting the energy to the next molecule. That is why the water ripples are created in all the directions, right? So whatever extra energy the pebble gave it to the molecules, the same molecule is being redistributed again, right? And that energy is being propagated in the various directions. So it is the propagation of energy in various directions, and this is called wave. You understood
Yeah.
the concept? Yeah.
Yeah.
So that's what happens, right? This is the
Yeah.
thing. So energy, not the matter. Just see this thing. In this case, um, we can say that the water ripples look like this.
Yeah.
So energy is being, suppose a disturbance was created over here,
Mm-hmm.
then the energy is being transmitted to both the directions.
Oh, okay. I think I know how this anti-gravity system works for the water area.
How? Tell me.
Okay.
Enlighten
So
me.
rock is going inside the water. The water from like close to the outside, but like it's yeah, like it like pushes itself to this point of an impact, and then it will like slide up, and then it will go down. It's like that, I think.
Okay, yeah, you can say
Like
that. A little bit, right? So up and down because of that thing. So just see this thing in this case. If I place a leaf over here, like let us say that one leaf is placed over here.
yeah,
But
leaf.
this disturbance, right? This is the pebble that will create the disturbance.
Yeah.
It is the source of disturbance.
Mhm. Also, I think there's something called water density or something like that. I forgot the name of it. Density, not density.
Yeah, water density is there.
I forgot the name of it, but yeah, it's like
Uh,
if you put a leaf on, for example, like it mainly happens to lily pads. So if there's water around it, and you're probably wondering like, how is the water not going onto it,
oh,
only around it?
it's surface tension. Do you know that?
Yeah, I forgot the name, but surface tension. Yeah.
Yeah, surface tension is responsible for that.
Okay,
Okay,
this probably has nothing to do with that, but yeah,
here, just tell me one thing. If the energy is propagating in this direction, energy is propagating in this direction. But
yeah,
you see that you can see the water ripples moving away, right? You can see the water
yeah,
ripples moving away. Like it's propagating in this direction. But if you put a leaf on its path, like suppose this is the leaf on its
yeah,
path, then this leaf does not move with the water ripples. Rather, this leaf will just vibrate, right? What does that
mhm,
mean? The molecules which are holding the leaf, they are just vibrating up and down, right?
yeah,
While the wave is propagating in this direction, the particles are just vibrating up and down. They are not moving along with the wave. Rather,
yeah,
wave is just passing through it, right? Extra
yeah,
energy is just passing through it. They do not want to keep this extra energy. They just transmit it to the next molecule until it reaches the bank of the river or the pond, right? Wherever you're creating the pond, wherever you're creating this disturbance. That's what happens. This is how the wave propagates.
yeah,
You got the picture, pretty much picture of the wave propagation, how this happens. But
mhm,
in many cases, like where there is no material, like electromagnetic wave, it can travel through the space also, where there is no matter at all. It can travel through the vacuum also. In that
yeah,
case, we create a different kind of disturbance. Like electromagnetic means we can change the electric and magnetic field, and that kind of disturbance creates the wave. Okay.
yeah,
Okay. So this is pretty much the idea of wave. It is the propagation of energy from one point to another, and there is no transportation of energy during the wave propagation. This is what you have written.
Um, I wrote down the propagation part.
Yeah, propagation
Yeah, from that part to so from it is the propagation of energy to
right here to here.
yeah,
I'm
that entire
just
thing.
writing this much.
Yeah.
You have taken the notes from here to here, propagation, right? Okay, fine. Here to here. Next, different types of waves
Yeah.
or types of waves. Very simple.
Hmm.
So, how many types of waves you know?
Sound wave, heat wave. Wait, does heat wave count?
Types of waves means there are so many waves. We are categorizing, classifying those waves in one of these waves. Let us just talk about these things. Like,
No.
what are the examples? Okay, examples of waves. You first tell me examples of wave.
Would light wave be?
Yes, correct. Okay, one by one, right? Let's just write it down. You said light wave.
Mm-hmm.
Then
Sound wave.
sound wave. Okay. Then
Um, would the wave in a microwave be counted as one?
okay, microwave is a wave. Yeah, correct.
Okay. Um, then there is okay, so light, sound, micro. I don't think you would
Water
say
ripple,
okay,
water
water ripple.
ripple, and seismic wave. What is this seismic wave?
Oh, seismic waves. Yeah, I forgot about those. Those are the things inside the earth that cause you know,
Earthquakes,
yeah.
right? Earthquakes. So this is the thing. And what else? X-ray,
X-ray. Oh, those are waves. I didn't know that.
yeah, gamma rays, any kind of radiation is just wave. Heat waves,
X-ray. Uh, that wave. X-ray. Heat. Oh, okay, I was right. Heat waves are the thing.
see that this symbol is called gamma.
Oh, gamma. Okay, I didn't know that. I only knew what beta and alpha were.
Alpha, beta, gamma, right? Alpha, beta, gamma.
Okay. Though it looks like a Y or an R.
Yeah, slightly different from Y, right? But it is exactly Y. Yes. So these are the examples of waves. Now, these waves can be classified into three broad categories.
Mm-hmm. Categories.
Or we can categorize these waves in various ways. Like we can categorize the way its particles propagates, the particles vibrates on the basis of the vibration of the particles or the variable properties. Then first, let us just talk about this one, which is which is given in your book.
Yeah.
Types of waves.
Oh, yeah, types of waves.
Mechanical wave,
Oh, that's a thing.
mechanical wave, and second is electromagnetic wave,
Electromagnetic.
and the third is matter wave.
Matter.
So mechanical wave, this type of wave requires a material medium for its propagation. It does not require any material medium.
Wait, are radio waves counted? Or
Yes, radio waves are also there. Correct.
So which one of those three would raised like radiation types like fall under?
Okay, here, right? Matter wave. Okay, first let us just define this thing. The energy associated with the matter, the energy associated with the material particle is called matter wave. We will talk about it. And now let us just categorize this thing. You will see this thing. Um,
Oh
here,
wait, think
okay,
I think I
right
know
up.
where some of them go, but electromagnetic waves.
Okay. So like
Um,
mechanical wave, can you tell me some names of mechanical waves? Like
mechanical waves.
out of these things, can you categorize these things like which one is, let us use the symbols M for mechanical wave,
Yeah.
E for electromagnetic wave, and M for matter wave.
Oh,
Out of these things, can you tell me like here, light wave is what kind of wave? Mechanical wave or
okay.
electromagnetic?
So for light matter, I think.
No. Light, you just see that. Light, can it travel through the vacuum? You
No.
see, electromagnetic waves can travel through the vacuum also, right? Can
Yeah.
travel. It can travel
Through the vacuum
through the vacuum.
cleaner. Vacuum cleaner. Okay, sorry. Um.
It cannot travel through the vacuum. Can you travel through the vacuum? Is there any wave you know that cannot travel through the vacuum?
Wait, when you mean by the vacuum, do you mean the vacuum cleaner?
Vacuum cleaner. Okay, what do you understand by vacuum? In physics, vacuum means a very
Wind or something? Or a gust? Like, does it have anything with air or like,
like, let us say that there are two chambers.
yeah, two chambers. Yeah.
This is, let us say that this is chamber one, this is chamber
Chamber
two.
one, chamber two.
Okay. In this case, there are air particles like hydrogen, oxygen are there.
Mm-hmm.
There are although they are invisible to us, right? We cannot see air. Air particles are invisible to us. We cannot see.
Yeah,
And here air is filled. This is air filled chamber.
air fill chamber or air fill chamber.
And here completely nothing.
Uh-huh. Air filled chamber, nothing.
Absolute nothing. Right?
So like no
This
air
is
inside
called
that
vacuum. Yeah,
vacuum.
no, nothing. There is nothing. Only the free space is there. No air
Okay,
particles, complete vacuum, devoid of any material particle.
so just a void.
Yeah, it's
Just
just
void.
a void, devoid
Yeah.
of any material presence.
Yeah.
That is called vacuum in physics. Okay, so just see this thing. If you are, let's do one experiment to understand this thing. Like there is a chamber like this.
Yeah.
Um, let us say that electric bell, you know, electric bell.
Yeah. Electric bell.
Yeah. There is atmosphere, there is air in this case, and this is
Mhm.
electric bell.
Electric
Electric
bell.
electric bell inside, right?
Yeah.
Electric bell inside, and there is wire to it. Electric
Yeah.
bell. There is a gong in it which keeps
Hmm.
on hitting on the gong, and
Yeah.
the you hear the bell sound, right? Bell ring. So here, just see that if you use a suction pump,
Suction.
Suck all the air
Mm-hmm.
with the help of suction pump.
Yeah. Suction.
So when you
Pump.
start taking out the air, when the first time when you turn on the switch, then the bell will start ringing and you will hear the ringing, right? You will hear the ring. But as you're starting to take out this air, as it is, the vacuum is being created, right? Inside, you're
Mm-hmm.
taking out all the air inside. It means you're creating a vacuum inside. So as
Yeah.
the air is getting less and less denser, then you will stop hearing the bell. No matter the switches is still on, but you still can't hear this thing, right? When the air is completely sucked out, then the bell ring will completely vanish. Although the switch is on, it means sound cannot travel through vacuum. It needs
Yeah.
material medium to propagate. So I say something and you hear because your speaker on your laptop maybe is
Yeah.
making the air around vibrate,
Vibrate.
right?
Yeah.
And that vibration is somehow being transmitted through the particles of the air to your eardrums, and they are
Yeah.
making your eardrums vibrate, and that's how you hear things, right? Or we have
Yeah.
talked about we have talked about sound wave, right? We have already discussed sound wave. I've taught you, right?
Mm-hmm.
So that's how it goes. So it means sound cannot travel through material wave. It means one of the examples of mechanical wave is the sound wave.
Yeah. Sound waves. Yeah.
For example, sound wave is the mechanical wave. Sound wave.
Mechanical.
Now tell me which out of these things, which are the mechanical waves? Can you name this thing? Sound
Uh,
is a mechanical wave.
sound.
Microwave?
Microwave is a mechanical wave.
No.
Oh.
Microwave is an electromagnetic wave because it comes out of electricity. This wave,
Oh.
right? This is electromagnetic wave. Water ripple,
Matter wave.
mechanical wave.
Oh.
Size, seismic, because matter is
Um.
involved in water ripple, right? Without water, how can you create the water ripple,
I
right?
thought water was water. Is that matter wave?
What?
I thought water was matter wave because water liquid.
Yes. Also, seismic waves.
Seismic wave can be a mechanical wave.
Correct. This time you're right.
Yay.
Mechanical wave. And X-ray,
Um, Electromagnetic.
electromagnetic gamma rays,
Same for electromagnetic.
electromagnetic heat waves.
Mechanical.
No, they are also electromagnetic waves, right? All the
Oh,
forms of heat waves or radiations are just electromagnetic waves.
oh, so that's
Hmm.
also electromagnetic.
Yeah. So mostly you will come across only two kinds of waves, mechanical wave or electromagnetic waves.
Uh-huh.
Matter wave is such a difficult wave to understand. This is newly discovered wave. This is associated with the material particle procedure. Light sometimes behaves like matter and sometimes behave like a wave also. So there was a scientist who hypothesized that all of us are just waves.
Oh,
Like you are also wave, I am also wave. And we
yeah.
have wavelength also. But why this wave feature is not dominant? Like why can't we experience it? Because of our mass. So
Yeah.
energy associated with every matter is called matter wave, right? Simple. Roughly, you can just understand this thing. No need to go deeper into this thing because there is one complete book. There is an entire book for this thing, right? So for now, you just have an idea about this thing that matter wave simply means the energy. Sorry, the wave associated energy. Sorry, I said energy. Wave
Uh,
associated. The wave associated with
Material particle.
the wave associated with the material particle is called matter.
Matter.
Right?
Yeah.
Write down this thing also. Examples
Yeah.
of wave and types of waves.
Okay, so I'm gonna just make this. Okay, so light wave is also it's kind of a tiny bit difficult to find which one is M and
Hammond?
like mechanical wave and matter wave are kind of the same M's, but one of them's like blue, I think.
Okay, okay. My mistake. Why
Um,
am I using the same thing? Okay, M. Usually just see that matter waves is hardly experienced, right?
mhm.
So this is matter. This is, you can say this matter.
Okay,
Anyway,
so
matter wave, we are not even discussing these things.
okay, so the blue one is electromagnetic.
Yes.
Okay.
A
And that one is light wave is
light wave is electromagnetic wave.
okay. Lots of electromagnetic ones.
Electromagnetic waves, yeah,
Yeah.
I will give you an idea about that. Although that's beyond your syllabus, at this time you won't be able to understand.
Yeah, microwave, um, water ripple. Okay, so seismic wave is matter. But I think all that seismic wave stuff is probably going what a seismologist would know, I think.
Yeah, correct.
So, oh,
Seismology. Oh,
there
you're
it is.
interested in geography, so what do you want to be when you grow up?
Um, it's nothing to really do with geography, but it's kind of something to do with health, I guess.
Something to do with?
Yeah, it's called you know, anesthesia, like
Yes, I know that.
anesthetist, I don't know, but
Oh, you want
yeah,
to
yeah,
anesthetize people.
yeah.
Anesthesia? I've never used it. Have you?
Hmm?
Anesthesia?
Yeah,
Um,
anesthesia.
making a part of a body numb, right? So that you do not
Yeah,
feel any
that one.
pain. That is anesthesia.
But that will consider some studying.
Of course, you have to study biology for that.
Yeah. Hang on, wait. Oh no, wait. Oh wait. Hang on. Wait, which ones of these are mechanical? I've kind of put way too much on electromagnetic.
Yeah, M is just these things.
Oh gosh. Wait, water ripples,
Sound sound is mechanical wave, water ripple is mechanical wave, seismic wave is mechanical. That's it. Rest of the other are just electromagnetic waves.
oh, so no matter waves or matter.
No matter waves, no matter waves.
So water ripple. What else? Water wave. Would a radio wave be? No, no, I can't. Never mind. Um,
Radio wave is an electromagnetic wave.
what else? Light? No, not light wave. No, wait. So sound.
Mechanical?
I think so.
Yeah, sound is mechanical because I just told you that in the vacuum you cannot communicate with your friend, no matter how loud you are. You think that you're shouting, but you're just
Yeah,
stressing your vocal cords. Your friend
yeah,
won't be able to hear it. You need a medium, material medium, to communicate with each other.
yeah.
Right? That is the thing. On the moon, like suppose You do not have a suit, and you're
Yeah.
talking to your friend. Will your friend be able to hear you?
No.
He cannot hear you, right? Because on the moon there is no atmosphere.
Yeah.
So you cannot talk to your friend on the moon, no matter how much you shout.
Yeah.
It's
So water ripple sound. Hang on. Water ripple sound. Okay, no. X-ray, gamma ray, heat
seismic
waves,
waves.
radio waves.
Only three, right? Only three are the
So I only got water ripple sound and
seismic waves.
oh, seismic waves are.
Where is Vivan? He's not coming to us.
Oh god. Wait, it's already time. Oh,
Yeah,
it's
it's
6
already time. Yeah.
Viva.
Where is he?
Oh, should I wait? Do you wanna like redo the meeting thing or?
Okay, we'll write it down in the next class, right? We'll leave it. How much you have written?
Basically, all of this basically, except for the diagrams.
Okay, except for the diagrams. That's fine. Okay. So next class, we will have it after a month.
Yeah,
Okay.
yeah.
Okay, then I'll just end the session and then just
Yeah.
join the session.